Okay, let's see if we can fix this Redlake Motionscope. If you saw the last teardown video, when I put it back together, it wasn't working properly. The power supplies were making noise, and this, I think its regulator was getting very hot. So I disconnected all the cables except for power, and when you turn it on, that problem seems to be gone away. And if we just connect this up to the video output, you see we are getting proper video output on the scope. If you cycle power, you can see the micro is drawing something to the screen. You can see the video changing, so it is working somewhat. So let's start plugging things back in and see what causes it to stop. Here's just the monitor. That seems to be okay. It's not making that hissing noise that I was hearing. Yep, so that comes up. This is the same garbage image we were seeing when I first tried it before. Now with the camera module plugged in, and now that's making the hissing noise. And it's not doing anything, so yeah, something seems to be wrong with the camera, or camera module. Just pulled this out and I think I know what might be wrong. This bottom card is, the connector is one pin shorter than the connector on the edge card, so I think if you look at the alignment here, I plugged it in the wrong slot. I hope that hasn't blown anything. Okay, that's back in the right position. Let's see what this does. Okay, that seems better. It hasn't blown up yet. Let's connect it back up and see what it does. Okay, we now seem to be back to where we were before. If we play, yeah, we get the random data. If we record for a second and then stop, I think it actually is recording something. Eventually we'll get to the to that. There's what we recorded, but it's all white for some reason. So let's take a look at that. Let's take a look at the output of the. We'll take a look at the video ADC down there. Just probing some of the outputs, or what appear to be the outputs of the video ADC. They're all stuck at 5 volts, so something is causing this to output all ones. That's why it's white. Okay, I think I've narrowed this down a bit. After injecting a signal into the input from the CCD amp, I didn't see anything on the input of the video ADC over here. It seems to go. The signal seems to go through this 8818 op amp, which appears to be operating improperly. It's getting the positive input is higher than or lower than the negative input, but the output is still high. And the golden rule of debugging: thou shalt check voltages. So let's check the positive rail. It is 5 volts, and the negative rail 0.8. That does not seem right. I would expect ground or some negative rail, so let's have a look at this. Perhaps one of the power supplies is bad, or there's a bad connection somewhere. And the output being stuck high matches with having this white video. If I ground the input to the ADC, you can see it goes black. So the ADC is working properly. Okay, the minus 5 volt on this is supplied by this 7905 here. And I've disconnected these other cables, and now the minus 5 is working just fine. So something's overloading it somewhere. The basic setup for these regulators is a 34063 switching regulator, followed by a linear regulator for both the positive and negative supplies. The switching supply produces about minus 17 or plus 17 volts, and that's regulated down to plus and minus 15 by the linear regulators, because they probably wanted the low noise from linear regulator. The 7905 on this is being supplied by a minus 15 volt rail, or at least it was minus 15 when this was unconnected, but now that rail is at minus 0.3, so something is wrong. There's this trace running over here to this, which seems to be, I wonder if this might be a linear regulator, so we'll have to check that. But I'm suspecting something in the camera module is overloading the minus 15 volt rail. The minus 15 volt supply runs along here under the board over to the camera connector, and there's some filtering with a bunch of ferrite beads. Actually, It's these little things which have looks like a wire going through, a bead here, the wire goes around, and this little axial ceramic capacitor in the center. And it looks like they've got the pin out wrong, so they had to change it around. I don't know if that, maybe they changed the bead, or they just got the, the things they got wrong. They probably just got the pin out on this wrong. Anyway, I have so this is how to measure current. If we turn it back on, we're getting about minus, measurements, minus 1.5 amps on the minus 15 volt supply, which is currently at minus 0.3 volts. And the frequency is synchronized to the switching regulator, so I think that's where the ripple's coming from. So something inside this module is short-circuited. From minus 15 to ground, we have pretty much a dead short. So let's start pulling out some of these boards until we see, and then we can see which board actually has the short on it. Okay, let's pull out this board. Short's still there, so that's not the problem. This board. Short is still there. This board. Short is still there, so it's on this end board. That's easy, there's not much on that. The only thing on this board are a few tantalum caps, and what do you know? This one is short circuits, so I think we found the problem. These are, what is this? 10 microfarad, 25 volts, and they're running at 15 volts. That's kind of pushing it. So let's swap that out for a new one. Probably swap all the caps on that board, and we'll give it a go again. Both plus and minus 15 volt caps are now swapped out. Yeah, failures in tantalum capacitors are quite common. They have to be derated quite a bit, and they have to be run much lower than their voltage rating by something like, I forget the exact factor, but it's something like 2 or 3 times. And they haven't done that here, so capacitors, tantalums run near their ratings often fail, and they typically fail short circuit rather than open circuit like other types of caps. And let's see what this does now. Okay, we got that other pattern that we got before. I don't know what it is. Before I'd rebooted it, and then we got the white image. Let's see. Let's check the supplies at least. Minus 15 is good. Plus 15 is good. Minus 5 is good. It all seems to be working properly. Woohoo! It's running! After rebooting it a few times, it came up, and now it's all working. Now we'll have to have a play with this thing. That'll probably be for a separate video. Hope you enjoyed this repair. Thanks for watching.